You've learned the law of reflection. The incident angle equals the reflected angle for a ray bouncing off a mirror. But how exactly does this law cause you to see an image of yourself when you look into a mirror? Here's a little diagram to help us understand. A person is standing in front of a mirror. The mirror is a line because we're looking at it edge on. Light is bouncing off diffusely off every point on the person's body. Some of those light rays will hit the mirror. Of the many rays that bounce off the person's foot, I've drawn 3 of them here, and they are color-coded as green, red, and blue. The colors don't represent the color of the light. They just allow me to distinguish the different rays. The ray that I've drawn in blue hits the mirror here and bounces off. The short black line here is the normal. It is a line perpendicular to the mirror that we use to measure our angles relative to. Here's the incident angle, here's the reflected angle, and you can see that they're equal. The ray drawn in red hits a different spot on the mirror. Here's the incident angle, and the reflected angle is equal to that on the other side of the normal, so the ray reflects in this direction. The ray drawn in green hits yet a different spot on the mirror. Incident angle equals the reflected angle, and the ray goes off in this direction. Notice that the 3 rays coming off the mirror are diverging, just like the 3 rays coming off the foot were originally diverging. In fact, they're diverging at the same angle. As seen from the left-hand side of the mirror, the rays appear to be coming from a point around here. We can find out exactly where they appear to be coming from by tracing back each ray in a straight line as if it had come through the mirror. And here are those lines traced back to where the rays appear to be coming from. The image of the person's foot will appear right here. Keep in mind that these 3 reflected rays are not necessarily the ones that you are going to see with your eye. For you to see those particular rays, they would have to be going into your eye. The actual rays entering your eye would probably be hitting somewhere around here and reflecting to your eye. I'm choosing this set of rays that make much more dramatic angles for you to see where they appear to be coming from. I could draw, instead of 3 rays, I could draw 1,000 rays. Each bouncing off the mirror at different places, they would all appear to be coming from here. Now let's look at the rays coming from a different point on the person's body, specifically the nose. A ray drawn in blue from the person's nose hits here and reflects this way because the incident angle equals the reflected angle. The ray drawn in red hits a different spot, and the ray drawn in green hits yet a different spot on the mirror. And like with the rays from the foot, we can trace back where those rays appear to be coming from behind the glass. It appears that the rays are coming from this point. The image of the person's nose is behind the glass, the same distance that the real nose is in front of the glass. And the same thing happens for every point along the person's body. The corresponding point behind the glass is where that part of the body will appear. We call this a virtual image. Virtual because the rays are not actually coming from behind the glass. What's behind the glass? Well, perhaps your medicine cabinet, or just the wall if the mirror is attached directly to the wall. The light is not actually coming from behind the glass. It just appears to be so.